Hi everyone, this is video 1 of Unit 2, looking at motor skill classification. We do have two resources regarding this topic. The first are the first few pages of Chapter 2, and then there is a handout on something called Gentiles taxonomy, which will be the topic of video 2. So be sure you have that ready when we're going over that topic. Again, I'd like to sort of refer back to our course objective that relates to this topic. So our course objective regarding motor skill classification is that the student will be able to describe the components of the one- and two-dimensional motor skill classification systems and apply the classification system in physical rehabilitation, physical education, fitness, and/or sport contexts. Video 1, this video, will be covering the one-dimensional classification system, and video 2 will be covering Gentiles taxonomy, or the two-dimensional motor skill classification system. And why is this important? Well, this is providing a basis for identifying similarities and differences among skills, which allows for a better understanding of how humans perform and learn skills while working within various professions related to health and fitness. So what we'll look at towards the end of video 2 is an application of the two-dimensional or Gentiles taxonomy classification system for how we can progress skills, progress skill development. In other words, if we have an end goal that is a somewhat complicated skill, how do we build up to that complicated skill? What more simplified or less complex skills can we perform to develop that more complicated skill? And that's the basis of our discussion question for the week. But before we get into the classification systems, I would like to first discuss what a motor skill is. This is a very fundamental concept in motor control and motor learning. There are specific characteristics to a motor skill. One is that it is considered an action goal, in that the movement is goal-oriented. So there is a very specific, purposeful outcome to the movement. Another characteristic is that the motor skill will be performed voluntarily as opposed to involuntarily. And a motor skill does require head, body, and/or limb movement. So our previous description of a motor skill uses the terms action, movement. Are they the same thing? Well, the answer to that question is not exactly. We can describe an action as a goal-directed activity that includes body and/or limb movement. Again, the idea of it having a specific purposeful goal is embedded in that definition, whereas a movement is what the body and limbs do when an action is performed. So there may not necessarily be some type of goal or purposeful action in that case when we're just talking about movement. And why do we make this distinction? Well, people initially learn actions, but then people adapt their movements to achieve action goals. So you could simply be learning how to throw a ball, for example, and there's no real goal to throwing the ball, but perhaps you want to throw a ball because you want to play baseball or you want to play softball. So then your actual action goal would be related to whatever the particular context is for that sport. So now this has brought us to our first classification system, or taxonomy. You can generally describe taxonomy as a classification system that's organized according to relationships among the component characteristics of what is being classified. So our first system, or first taxonomy, is something referred to as a one-dimensional classification. And the first dimension, or one of the dimensions for this classification system, is the primary musculature required. In other words, are very small muscles being used to primarily perform the skill, or are very large muscles being required to primarily control or perform the skill? So we can have a spectrum, obviously, because there are very small muscles in the body and there are very large muscles in the body, and then we have a whole bunch in between. So we can create the spectrum between something called a fine motor skill, where small muscle groups are used, versus the other end of the spectrum of gross motor skills, where large muscle groups are being used. And some examples of a fine motor skill are things like typing, threading a needle, speech. Obviously, typing and threading a needle, we're primarily using our hands, so there's very small musculature there, and speech involves muscles that are located in the neck, so that would also be fine motor skill as well. Whereas our gross motor skills, many of the motor skills involved in sport and activity would be considered gross. Tackling, jumping, sprinting, you're utilizing entire body movement, so many muscles ranging from small, including large, would fall into that category. Our second category within the one-dimensional system is the specificity of where actions begin and end. And the specificity is not referring to the actual geographic location or location in space of where the movement begins and ends. It is referring to, can you make a definite distinction between when in time the movement ends, or begins, I should say, and when it ends. So, for example, again, we have a spectrum. We have motor skills that are referred to as discrete because they have a distinct beginning and end to the movement. So generally speaking, these are considered to be single movements. Something like pressing a button, flipping a light switch, throwing a ball. These would all fall into the category of a discrete motor skill. There's a very distinct beginning and end to the movement. Whereas a continuous motor skill has an arbitrary beginning and end to the movement. And typically, the way that continuous motor skills are described is that they are repetitive. Things like rowing, walking, cycling. You can obviously walk on a treadmill. You're not really moving your location in space per se, but it is very difficult to distinguish when the beginning of the walking motor skill itself begins and when it ends, which is why it's considered to be a continuous motor skill. Generally speaking, our discrete motor skills are of shorter duration than our continuous motor skills. An example in motor control research that we'll see multiple times over the course of the quarter is something called tracking, or a tracking task. This is an example of a continuous motor skill. And generally, tracking can be described as where an individual attempts to follow a pathway or a track with a device via certain limb movements. Now, from a practical perspective, you're probably doing this every day when you're driving a car, where the road would be the track and the device to stay on the track is the car or the steering wheel. So, in research regarding motor control and motor behavior, generally this is following a cursor on a computer monitor. And there are three primary types of tracking tasks. The first type is called pursuit tracking. This is where we have two cursors on the screen. One cursor is controlled by the experimenter, and the other cursor is controlled by the subject of the experiment. And the movement of both of these cursors is shown on the screen. And ultimately, the subject will want to try to stay with or follow the experimental cursor. Then we also have something called compensatory tracking. This is where we have variations in the track combined with the subject's tracking to produce a single displayed value. So the goal in this case is to maintain a value at some constant location. And then we also have step tracking. This is where the cursor controlled by the experimenter jumps around the screen, a lot of times in very unpredictable ways. So the subject's goal is to respond to the sudden change. And this can be either pursuit tracking or compensatory tracking within the step tracking method itself. Within our second one-dimensional classification categories, we do have another type of motor skill. So we looked at discrete and continuous, which is a spectrum. And in between those two types of skills, we have something else. It's considered a combination category. And the motor skills here are called serial motor skills. Serial motor skills can basically be described as a continuous series of discrete movements. So something like dancing, shifting gears in the car, or playing the piano. When you shift gears, let's say you want to go from first to third gear, shifting into first would be one discrete motor skill. Shifting from first to second, another discrete motor skill, and from second to third, another discrete motor skill. But because they are performed continuously in the sense that it's one after the other, there's a very set sequence or a set order to performing that motor skill, it is considered serial. Very similarly with the piano, there's multiple keys, so every discrete skill would be considered tapping a key. But in order to play some type of song, you would have to string together multiple discrete movements in series, and generally there would be a specific sequence or order to that. The last category within the one-dimensional classification system refers to the stability, which one could think of as predictability, of the environmental context. So in this case, skills are categorized based on the level of constancy of the environmental setting. And the environmental setting can include things such as the supporting surface under which the motor skill is being performed. It could be the type, the number of objects that are involved, or whether or not there are objects involved at all. And of course, other people and how they're interacting with the main actor, let's say, in performing the motor skill. Within our stability of the environmental context classification, we do again have a spectrum of the types of motor skills. We have what's called a closed motor skill and an open motor skill. A closed motor skill is characterized by a skill being executed at the performer's discretion. The way in which this can happen is if the environment is very stable. In other words, the environment is static, it's not changing. So something like a free throw. The environmental conditions stay exactly the same every time you perform a free throw. The basket is the same size, the ball is the same size, the distance from the basket is the same size. There's going to be most likely some individual variation in how the motor skill is performed, but with regard to the environment specifically, there are no changes, which is what this category is referring to. And then we have open motor skills, where the execution of this type of motor skill is going to rely on the performer moving at a certain time and rate in order to achieve whatever the goal is. Another term for this is commonly referred to as a coincident timing task. And essentially what the individual is trying to do is adapt their movement to the dynamic characteristics of the performance environment. In other words, the environment is unstable. It is not static. It is most likely constantly changing. So for example, two sport examples are blocking a goal. Any type of goalie would be performing an open motor skill because every attempt at goal most likely is slightly different, and you can't necessarily predict 100% what is going to happen, although very skilled individuals can make some predictions based on body movement of the other performer who's kicking the ball or hitting the goal. So another example of this is returning a serve in tennis, for example. One of the main ideas behind serving is to try to hit the ball in a position where the other individual receiving the serve will be maybe caught off guard or ultimately miss, right? Because they're trying to win the point. So something like this is definitely shown with an ace, where the individual is unable to hit the ball back entirely, definitely suffering from the fact that it is an open motor skill. So we do have our individual categories within our one-dimensional classification system, but we can apply each of these to particular motor skills and see how they compare. So for example, a fairly simple motor skill would be snapping your fingers. This is considered a fine motor skill because you're using very small musculature. It is considered discrete because there is a very distinct beginning and end to the movement. And it is a closed motor skill because the stability of the environment is constant. There's no changing of the environment or anything related to that when you're snapping your fingers. Road cycling, however, is extremely different. By road cycling, I'm referring to a road race, not performing the cycling movement on something like a stationary bike. So it's obviously a gross motor skill because the primary musculature utilized in order to perform this skill is the lower extremity. So the muscles of the lower extremity, including hip extensors like the glutes and the hamstrings, and of course knee extensors, which can generally be described as the quadriceps. Of course, the calves are involved as well, upper extremity to a lesser degree. This is a continuous motor skill because it is difficult to identify a distinct beginning and end to a cycling movement. So it's continuous, and it would be considered open, specifically because it would be an open road cycling event where the environment is constantly changing. Not only do you have multiple competitors, for example, who may be interfering with your ability to cycle the way that you want, but the actual conditions of the surface you are cycling on can change, and obviously the direction based off of the actual track would change.